Hello, and welcome to Business Calculus Optimization, Inventory Control. An inventory control problem describes the issue of managing the costs of storing products. Whenever a product is produced, there is a cost to setting up the equipment and running it. This cost is usually fixed and somewhat high. Storing a product after it is produced usually costs a small amount per unit, so the total cost of storage depends on the total amount that you have in storage. The challenge of this problem is finding the minimizing cost between these two factors and determining the optimal production amount per run. We discuss production runs because we assume that the demand is constant, and so the reduction of product in inventory is predictable. For instance, if we have X Blu-rays produced per run and Y production runs per year, then the average amount of Blu-rays in inventory is X divided by 2. And we're going to use this value in our cost function. We see this demonstrated by the figures shown. So let's look at an example involving inventory control. A multimedia company anticipates that there will be a demand for 20,000 copies of a particular Blu-ray during the next year. It costs the company 40 cents to store a Blu-ray for 1 year. Each time it must make additional Blu-rays, it costs $250 to set up the equipment. How many Blu-rays must the company make during each production run to minimize its total storage and setup costs? What are those costs? And how many production runs will be necessary? Here we have the pertinent information from our problem side collected. $250 per production run and 40 cents storage per unit per year, in addition to 20,000 total units. Setting up our problem, we're going to use X to represent the production per run and Y to represent the total number of production runs. We need the product of those two numbers to equal 20,000, which is our total demand. So we're going to start there. Now, we use these equations here to give a relationship between our variables x and y. So we're going to solve for y in terms of x so that we can then generate a cost function of one variable. Our cost function is going to look like this. We know that it costs $250 per production run, which is represented by y, and it also costs us 40 cents per unit per year to store our Blu-rays. So the average number of units that we have in storage per year is going to be X over 2. So that's how we're going to show how many we have in inventory. What we're going to do now is we're going to take our cost function and rewrite it as a function of x, substituting in our value for y. So we're going to have 20,000 divided by x, replace y, and we'll do a little bit of simplification on the right-hand term and get 0.2 times x. Lastly, we'll simplify the left-hand term and see that in the numerator we're going to have 5 million divided by x. Now we're ready to take some derivatives. Sliding over here to the right, we're going to look at c prime of x, and it's just a couple of power rules, so it's pretty easy to evaluate these derivatives. So it's going to be negative 5 million divided by x squared plus 0.2. And we're interested where this equals 0. We can subtract from both sides 0.2 and multiply by x squared to get negative 0.2x squared equals negative 5 million. And then we divide both sides by negative 0.2, which gives us that x squared equals 25 million. We can take the square root of both sides of this equation and get a much nicer looking number of x equals 5,000. So this represents our production per production run. As a quick check, we're going to take the second derivative of our function to make sure that the second derivative test is satisfied. Again, it's another power rule, and we see that this thing is always going to be positive for positive production levels. So it tells us that we have a local minimum for our cost, which is what we wanted. All right, so let's plug in this value. We plug 5,000 into our cost function. And we see that the total cost for storage is going to be $2,000 per year. And to determine the total number of production runs, we plug in x to our equation for y, and we see that that value is equal to 4. So 4 runs of 5,000 units costs $2,000, which is a minimum for our problem. All right. It's time for you to answer a question now. Complete the exercise from the example, except now the setup cost is $200 and the cost to store a Blu-ray for 1 year is 50 cents. What is the optimal production level per production run? Is it 3,000 Blu-rays, 4,000 Blu-rays, 5,000 Blu-rays, or 8,000 Blu-rays? Thank you very much for listening.